Hello, it is Friday, April 10th, and today we're going to find the sign of the trig functions in each quadrant using ASTC. Of course, we'll explain what that means. And in order to understand this, we're going to start by understanding the unit circle. So the unit circle is kind of the basis of what a lot of trig is based off of. You don't really need to know the unit circle. They don't really ask you questions directly about the unit circle in this course, but a lot of trig stems from it. So I'm going to give you a brief little overview of the unit circle. So the unit circle is a circle that has a radius of 1 and its center at the origin. And we're going to say this is 1, 1, negative 1, negative 1. We're going to pretend, even though it's 10 boxes, we're going to say it's 1. So I want to talk about a point on the unit circle. So let's just pick any point. And we learned the other lesson where we make the triangle, and that's my angle. So I want to talk about sine and cosine of that angle. Well, since the radius is 1, then this is 1. Now, this is my adjacent, this is my opposite, and I'm going to call my adjacent, this is my x value, and this is my y value, correct? Since this, whatever this point is, this is the x value of that point, and this is the y value of that point. So sine of theta would be opposite over hypotenuse based on SOHCAHTOA, which is y over 1, which is y. So basically, sine of theta is the y value of this point. Cosine is a over h, which would be x over 1, which is x. So cosine of theta is the x value of this point. So what we get from that is any value on the unit circle is always cosine of theta comma sine theta. Since cosine of theta is always the x value and sine of theta is always the y value. And again, that's based on SOHCAHTOA and the fact that the unit circle has a radius of 1, which makes the hypotenuse 1. Now, another thing you need to know for this is tangent is always, well, let's take a look at tangent. Tangent is opposite over adjacent. So tangent would be y over x. And we just said that y is sine of theta and x is cosine of theta. So that's kind of a little rule you need to know as well. Tangent of theta is sine of theta over cosine theta. So what do we need to know? Any point on the unit circle is cosine of theta comma sine theta, and tan of theta is sine of theta over cosine of theta. So I'm going to kind of clean this whole thing up right now. Actually, let's do it this way. And then we're going to talk about the signs of the quadrants. We're doing a lot of talking right now, and then we're going to do some doing after that. But I want you to understand where all this stuff's coming from. Let's go purple now. So again, the unit circle has a radius of 1, a center at the origin, and we said that any point on the unit circle is cosine of theta comma sine theta, and we said that tan of theta equals sine of theta over cosine. That's what we've discovered so far. Now I want to talk about the signs. By signs, I mean positive or negative of each trig function in each quadrant. So in this quadrant, the coordinates of this point are going to be positive and positive, because in quadrant 1, the x value is positive and the y value is positive. So if it's positive, positive, that means that cosine of theta is positive, because cosine is the x value. Sine of theta is positive, a weird theta, because the y value is positive. And now tan of theta, well, tan, we said, is sine over cosine. which would be positive over a positive, which is a positive. So in this quadrant, they're all positive. Now let's take a look at Quadrant 2. In Quadrant 2, the x value of this point is negative, and the y value is positive. So the x value is cosine theta. The y value is sine. Now we say that tangent is sine over cosine. Well, sine is positive, cosine is negative, and a positive over a negative is a negative. So in this quadrant, only sine is positive. Cosine's negative, and tangent is negative. Any point in Quadrant 3, well, the x-coordinate here is negative, and the y-coordinate is negative. So the x-coordinate is cosine. The y-coordinate is sine. Tangent, again, is sine over cosine. Negative over a negative is a positive. So in this quadrant, only tangent is positive. The other two are negative because the x and y value are both negative. And finally, in Quadrant 4, well, the x-coordinate is positive. The y-coordinate is negative. So that means that cosine, the x value, is positive. The y value, sine, is negative. Tangent, again, is sine over cos, which is negative over a positive, which is negative. In this quadrant, only cosine is positive. So what we come up with, I'm going to kind of clean this up now. What we come up with is this. To help us remember this, we say all students take calculus. That's a little acronym starting in Quadrant 1 and going in, counterclockwise order, which we go in math. All students take calculus. Now, what these letters represent is what's positive in each quadrant. So in Quadrant 1, this is saying that they're all positive. So by all positive, it means that sine is positive, cosine is positive, tangent is positive. Quadrant 1 has the A, they're all positive. In Quadrant 2, this S is saying that only sine is positive. So sine is positive, and if only sine is positive, then the other ones must be negative. This T is saying in Quadrant 3 that only tan is positive, which means that sine is negative and cosine is negative. And finally, C in Quadrant 4 is saying that cosine is positive, which means that the other ones must be negative. That's how we use ASTC. All students take calculus. In Quadrant 1, they're all positive, so sine, cosine, and tangent are all positive. In Quadrant 2, only sine is positive, so cosine and tan are negative. In Quadrant 3, only tan is positive, so cosine and sine are negative. And in Quadrant 4, only cosine is positive, so sine and tan are both negative. So what we're going to do today is we're going to determine the sign, or which quadrant it's in, based on the signs of sine, cosine, and tangent. Let's quickly talk about the reciprocal functions. When I take the reciprocal of something, the sign doesn't change. If I flip something, I'm not changing the sign. So if sine is positive, then cosecant's positive. If cosine's positive, secant's positive. If tangent's positive, cotan's positive. If sine is positive, cosecant's positive. If cosine's negative, secant's negative. If tangent's negative, cotan is negative. We talked about these reciprocal pairs in an earlier lesson, and basically when it comes to the signs, when I flip something, the sign stays the same. So whatever the original trig function is, the reciprocal trig function is the same. If sine is negative, cosecant's negative. If cosine's negative, secant's negative. If tangent's positive, cotan is positive. If sine is negative, cosecant's negative. If cosine's positive, secant's positive. If tan is negative, cotan's negative. All right, we did a lot of talking. Let's do it. So it's saying that cosine is less than 0. So less than 0, if something's less than 0, then it's negative. Tangent is negative. So I draw my little grid. All students take calculus. Either one is positive or they're all positive. You can never have 0 of them positive or 2 of them positive. So if cosine and tangent are negative, that means that sine has to be positive, which means it has to be in quadrant 2. I'll say that again. Since it's telling me that cosine and tan are both negative, that means sine has to be positive. Which quadrant is sine positive and the other one's negative? Quadrant 2. Number 2, sine is greater than 0, that means positive. Tan is greater than 0, that means positive. I can't have 2 of them positive. I can have 1 or I can have all 3. Therefore, cosine must be positive. They're all positive. So that means it must be in quadrant 1. Number 3, cosine is negative, sine is negative. That means that tan must be positive. Again, I can't have all the negative. Either one's positive or all 3 are positive. So now I go to my all students take calculus. Where is tangent positive? Quadrant 3. Let's take a look at numbers 4, 5, and 6 together now. Now we're introducing some of the reciprocal functions. Cosine is greater than 0, so that means cosine's positive. Cotan. Well, let's make it simple. I don't want to bring in these reciprocal functions. So if cotan is negative, then tan is negative. If cosine's positive and tan is negative, again, I can either have one positive or all of them positive. Since only cosine is positive, sine's got to be negative. All students take calculus. Cosine is positive in quadrant 4. The ASTC stands for all, sine, tangent, cosine, not for the reciprocal functions, not for secant and cosecant. If you get the reciprocal functions, you find the reciprocal of it and go from there. So in number 5, if cosecant is positive, that means that sine has to be positive. Tangent is negative. I can either have one positive or all 3. Since tangent's negative, cosine's got to be negative as well. All students take calculus. Which one has only sine positive? Quadrant 2. I'm going to start you off on number 6. It's saying that tan is negative. Now, if cosecant is negative, I want you right now to think about what that means. If cosecant is negative, then what else do I know? Its reciprocal, sine, must be negative. Again, I want to work with sine, cosine, and tangent. So if I see a reciprocal function, I'm just going to basically convert it to its reciprocal, sine, cosine, or tangent. I want you to try and finish number 6 from here. I'll give you about 30 seconds. Okay, if tan is negative and sine is negative, then cosine has to be positive because at least one of them has to be positive. So I go to my all students take calculus. Cosine is positive in quadrant 4. So my angle must be in quadrant 4. So that's it. Again, I know we talked about a lot at the beginning. Any point on the unit circle is cosine of theta, comma sine theta. We also derived that tan of theta is equal to sine of theta over cosine theta. We then looked in all the quadrants, and we found that in quadrant 1, they're all positive. In quadrant 2, only sine is positive. The other ones are negative. Quadrant 3, only tan is positive. Quadrant 4, only cosine is positive. From there, we kind of use the All Students Take Calculus to see how we're going to memorize what's positive in which quadrant. And then from there, we used it to answer actual questions. So I can find the sign of the trig function in each quadrant using ASTC, All Students Take Calculus. Your classwork/homework is to finish signs of quadrants. It's a very short lesson, so I'm just going to say that you're going to have one day. I'm giving everyone an extra day to complete the assignments, but this is really a short thing, so I'm going to say it's due. I mean, it really should be done by the end of the weekend, but I'll give you until Monday night. But we are going to have a new lesson on Monday. I'm not going to give you the day off. Most days I'm going to give you a day off, but this is really like a half lesson, so I'm not going to, spend too much time on this. I am going to post a quiz. It'll be due Monday night, even though it really should get done, when you do this lesson today on Friday or over the weekend. All right, that's all I got for you. Enjoy your weekend. If you have any questions, reach out to me in Reminds. And that's it. Be good. Stay safe.